Welcome back to another one. Today we'll be going over DNA sequences and the different mutations they can give us. To start this video off, we'll jump right into an example of two different DNA strands. We're given a templating strand and a coding strand. We'll be looking at transcription, which is the process where you change DNA to transcribed mRNA through the coding strand. Here we have two beautiful strands of DNA. However, there's a problem here. The amino acids we're trying to code for can't understand the same language that DNA speaks. So to solve this problem, we're first going to flip the coding strand and change all the T's to U's so that it speaks the same language that the amino acids we're trying to code for speak. Once we've transcribed the mRNA to a language that the amino acids can read, we can start to translate them into the amino acids. So amino acids come in sets of 3. However, they start when a start codon is read. So instead of reading GGA, it would actually read AUG because that's where the start codon is. Then following it, we have all these amino acids. However, once we come upon UAA, which reads a stop codon, we stop, and we don't need to pay attention to the rest of the strand. In these strands, we can find 4 different kinds of point mutations, which is the change of a single nucleotide. We can classify these mutations as nonsense, missense, silent, and read-through. These mutations can be further classified as either a transition or transversion. A transition is a change from a purine to a purine or pyrimidine to a pyrimidine. A transversion is a change from a purine to a pyrimidine or pyrimidine to a purine. Going back to my language analogy, this would be like switching from a southern accent to a Midwestern accent. And this would be like switching from German to French. So I'll do an example of each, starting with a missense mutation. Since we're only changing one nucleotide, it's just going to code for a different amino acid. So here we're changing AAG, which codes for lysine, to AGG, which codes for arginine. And since this is a change from an A to a G, it is a transition. Next up, we have a silent mutation. The change here will be from a G to an A, which makes it a transition. AAG codes for lysine, which will change to AAA, which also codes for lysine, which means there is no change, making it a silent mutation. Next up, we have a read-through mutation where a stop codon gets changed into a normal amino acid, and the strand just keeps on going. Here we're changing an A to a C, which makes this a transversion, and we're changing it from a stop codon to a serine. Last one on the list is a nonsense mutation when you change a normal amino acid to a stop codon. Here we're changing lysine to a stop codon, and this is a transversion because we're changing an A to a U. That's all for today. Thanks for watching.